In this video, I just wanted to run through the solutions of the oxidation reduction questions that I gave you for homework. So the first question there in oxidation reduction was, what's the oxidation number of sulfur? So remember when we were doing this, you X the sulfur, oxygen is always -2. When is oxygen not -2? Just remember the exceptions. H2O2 or OF2. You don't have one of those exceptions here, so oxygen is -2. Then you multiply, so it's X minus 4 is equal to 0. There's no charge up there, so X is equal to +4, okay? In this instance, in the second one then, again, you're Xing sulfur's oxidation state, and again, the oxygen is -2. Remember when we were doing these in school, we wrote the oxidation number first, then you multiply. So X minus 8 equals, now this time it does equal to -2. So X was +6. Okay, so that was the first question. Question 2 then said that during the Olympics in Rio, the water in the swimming pool, all of that. Now, they gave you a balanced equation here, okay, and then they asked you, +O2, they asked you to use oxidation numbers to show whether the chlorine was oxidized or reduced. So we need to assign oxidation numbers now. Now, you're asked specifically here about chlorine. So if I was you, I would call chlorine X. We know that oxygen is -2 because it's not our exceptions, okay? And OF2, there are only two exceptions where oxygen is not -2. And we know that sodium is +1, okay? So work it out then. +1 -2 plus X is equal to 0 because there's no charge up there. So X is equal to -1, so +1. Is that okay? So that's +1. Now where's the chlorine over here? X the chlorine over here. Again, sodium is +1. So if sodium is +1, then the X must be -1. And see what's happening now, look. The chlorine is going from +1 all the way down to -1. So it's being reduced. There's a decrease in the oxidation number. So you know that the chlorine is being reduced. And then for question 3, you were given two equations. Now, firstly, actually, you were told that the halogens are good oxidizing agents. How does the oxidation number of oxidizing agents change? Now, remember, lads, that if something is acting as an oxidizing agent, it itself is being reduced. And if it's being reduced, then there's a decrease in oxidation number. Okay, so you just have to say there actually it's being reduced itself. Okay, then you were asked to assign oxidation numbers to the equations there. So I'll just do the first one here now firstly. So if I that's a 2. And what have you got? You've got 2Br minus and 2Fe plus 3. So you're asked there to show that the halogen, now halogen is something in group 7. So this is the halogen here, that's in group 7. So you need to show that that's acting as the oxidizing agent. Now bromine here isn't bonded to anything other than another bromine. It's not bonded to anything else. So it's 0. +2 for the iron here, -1, look, and +3. So has the bromine been reduced? Yes, it has. And you just say the bromine has been reduced because it's there's been a decrease in oxidation number. Now, in the second equation that they gave you then, plus water, just write it down here now firstly, minus SO4 minus 2 and H plus, okay? Again, same thing, but this time you have to balance it. Not for this, isn't it? Now, I'm not sure about the X -2, so multiply then. X minus 6 is equal to -2, so X is equal to +4. +1 for the water, -2 for the oxygen, -1 here, X the sulfur here, -2 for that. That's a -1 there, or +1, sorry, I'll fill it in. Okay, sulfur now, X minus 8 does equal -2 this time, look. So this time X is +6, okay? Now remember when we were balancing these equations, we had to pull out what's being oxidized and to pull out what's been reduced. So what has gone up in oxidation number? Well, the S has gone from +4 up to +6. So the SO3 minus, now remember oil ring. So loss of 2 electrons and SO4 minus 2. So +4 to +6, okay? What's been reduced? Well, look, the chlorine is not here and it's -1 here. So the chlorine has been reduced. Now be careful, there's a subscript there. So each chlorine atom is going from 0 to minus, so it's gaining 1 electron. So when you attach the subscript, it's going to be 2. Now look at what you notice about your electrons. They're already balanced. So you actually don't have a ratio to insert into the equation. So all you have to do then is go and check that your atoms are atoms are balanced. So we have Cl2 plus SO3 minus 2 plus H2O. Now, you have 2 chlorines over there, so I'm going to put a 2 in front of the Cl minus. The sulfur is balanced, isn't it? Let me just check that 1 second now. The sulfur, 1 S there, 1 S there, yeah. Now, what about the oxygen? 3 and 1, that's 4, and 4 over there on the right as well. Now, the only thing is the water. I have to put a 2 in front of that, don't I? Now, remember to check your charge now. So, no charge on that. Minus 2, no charge on that. Minus 2. Minus 2 plus 2, so they'll cancel, one of the plus 2s will cancel with the minus 2 there, and that's going to give you the minus 2 equals minus 2. Now, in the last part of that, they said, why does the oxidizing ability of halogens decrease as you go down the group? Now, remember, you'd have something like chlorine, bromine, iodine. So they're asking you, why does the oxidizing ability, okay, so they're saying oxidizing ability decreases as you go down the group. What does oxidizing ability mean? You need to work that out in your head for yourself. Oxidizing ability means that they're going to be reduced themselves, okay? Very often in the question, you know, preceding parts of the question will kind of help you with the last part, you know, so just bear that in mind. So the halogens are oxidizing agents because they're going to be reduced themselves. Now, why does that ability decrease as you go down the group? Okay, now the reason for that is because the electronegativity values are going to decrease, aren't they? So chlorine has a greater attraction or a greater pull. It's going to be able to gain electrons. It gains electrons easier. But why? That's what they're asking you. Okay, so why does it decrease? Well, firstly, you're going to say that you've got an increasing atomic radius. So as you go down the group, the atoms are getting bigger. So remember that the nucleus is the protons are in the nucleus. Positive force of the nucleus, it's further away from the outermost electron. So atomic radius increasing. And you're getting an increase in the shells, aren't you? So what will also increase then will be screening. So screening is increasing. Or if you just wanted to say the electronegativity values are decreasing, that would give you, there's only 3 marks going for that. So just one of those points will do you fine. So probably electronegativity value decreasing is the most obvious. So chlorine has the greater pull or greater attraction. Remember, what does electronegativity mean? Relative attraction that an atom has for the electrons. So just 1 point, there was only 3 marks as I say going for that. So 1 point would be fine for that there.